accurately determine the gate opening angle. So if the client says, no, I want this gate to open 110 degrees, you say, no sir, it's not going to be possible because of the pillar depth of your gate. So we can give you 90 degrees, but not 110. So by doing a few steps, you can determine, will this gate be able to do the angle that the client wants, or the angle that you want it to do. Okay? So we're going to look at the Z value. So how do we get the Z value? This is your pillar, and here's the gate closed. So you take 1 meter from the hinge, you measure 1 meter, and you mark an X on the ground. Then you open the gate, right? Now it's open. This is about 90 degrees. Or you open till the point you want it to open, where you specify the client wants it to open to. Then you say, okay, 1 meter again, and you make an X on the ground. And then you take a tape measure and you measure the distance from that point X to this point X, and you measure the distance, and then you'll get your Z value. Okay, so let's do it quickly. So there's my gate closed. Alright, so you take from the hinge 1 meter and you mark it with an X. Then you open the gate. And look at that CG we're doing there. And you open the gate, and then obviously now the gate's open again from the hinge, center of the hinge, 1 meter, you mark an X. Alright? And then you take your tape measure and you measure your Z value. So, if your value, your Z value, if it's between a meter to 1.133 millimeters, you can have this opening angle. Yeah, if you, let's say, if you want 90 degrees, you need to say this length's got to be about 1.4 meters. Then I will be able to do a 90 degree opening. Okay, so that's one of the first things. Not so important, it's still important, but this is not your A, B, and your E value, but your Z value just tells you what you'll be able to open this gate.
So Z value is actual Pythagoras theorem.
Why?
The Z value can get it as in mathematics Pythagoras theorem.
No, I don't understand what you're saying. Why?
I mean, that Z value.
Yeah?
You can get it with the formula of Pythagoras theorem.
No, you just, yeah, it's just 1 meter, and you take the length. So it's purely the length of this hole between that X, because your gate is now obviously, there's your pillar, your gate, there was your closing angle, there was your opening angle, and then you've got that's your length. And that length will tell you if I'm running between 1,000 to 1.1, or let's say 1 meter to 1.1 meters, I will have only up to a 69 degree opening angle. If I want 90, if the client insists he wants a 90 degree opening gate, then this value must be at least 1.41 meters. Okay. So this will determine, will this gate be able, because it might be, if the client says I want 110 degrees, but there's a wall right here, then obviously this gate can't open more here because there's something blocking it, or there might be a tree or something. So you open it till the point where, before it starts knocking something, then you mark your spot, and then you know, okay sir, the values tells me that I won't be able to give you more than whatever the Z value is. Okay. Once you've done that, now you've got to also look at some key terms, the wall minimum. So the wall minimum from the gate in its open position, you should have at least 200 mils, 20 centimeters. Because that is basically the motor with the bracket. That's about your angle. So if you've got less than 200 mils, you're going to have an issue with maybe, because you're going to mount the motor there. If there was nothing, if this wall was basically here or something, then this motor won't fit. This gate's going to actually press the motor or bump the motor into the wall where it's now opening or closing to. So your minimal wall distance should not be less than 200 millimeters, 20 centimeters. Okay, that's to compensate or to make sure that you're not going to damage the motor. And your angle. Because think to yourself, if I'm now the motor, here's the gate. If I'm like this, for me to open this gate to here, it's going to be so difficult. Because you know your angle of attack, if I'm like this, it's going to be a lot easier for me to do this. But if I'm like this, to open something, it's the motor's going to struggle with the wind and whatever. You're just making life difficult for the motor. So you've got to have a minimum of 200 mil so the motor can be installed properly with its A and B value, which we're getting now. Okay, so obviously you'll see there's your wall, there's your hinge, the gate in the closed position, the gate in open position, and your side wall or whatever is here. There could be a tree here or something. It could be something that's blocking the motor here. But you have to have at least 200 mils of opening between the motor that's going to be here and whatever else is going to be here. Then another thing you need to look at is, which is quite important, especially for inward swing. Outward swing, not so much. Inward swing motors, you've got to make sure of your E value, which is your pillar depth. So if your pillar is 200, or let's make it 400, it's quite a strong pillar, 400, which is 0.4 meters, then the center of it will be then 200, obviously, give and take, and that's your pillar depth, so that's your E value. And that is quite important, especially knowing what you will be able to, this will guide you to know what your A and B value must be. Okay, so your E value is quite important if it comes to inward swing. Outward swing doesn't matter so much, but inward swing, a lot. Okay, so the pillar depth is basically the center of your hinge to the edge of your pillar. Okay, and here it comes to the values. On the vantage 400, your pillar maximum should not be more than, if you want 90-degree opening, you should not be more than 175 millimeters. Okay, so that's 17 centimeters basically. If you want 100-degree opening, then your pillar can't be more than 155 millimeters. Alright, and obviously if you want more, 110 degrees, your pillar should not be, or cannot be, if I say that not should be, cannot be more than 145.
When you talk about the pillar maximum, are you talking about the E value?
Yes,
Okay.
yes, this value. So this should not be more than 75. If I want 90 degrees, this cannot be more than 175. Okay. So if it's 200, then you might have an 80-degree opening or 85 degree. But yeah, your pillar depth is quite important when it comes to, which is your E value, which is quite important to what you can actually be able to do. And from this, you also work out your A and B value. This will then tell you, if your pillar is this, then your A and B should be this. But you can play around a little bit with the values, a little bit. Okay, so there's your vantage 400. On the vantage 500, you can see you've got a little bit more room, or you can have a bigger pillar. So people asking when do I install a 400, when do I install a 500? It's not the strength, the 500 is not stronger than the 400. It's the same motor, exactly the same, it's just the piston is longer. So you've got more traveling distances, meaning your pillar can be a thicker pillar. Because now the 500, you can have a pillar of 245 instead of 175. You can see everything else is higher or bigger on the 400, on the 500 than it is on the 400. Because now the stroke, that piston, that extra size of the length of the motor and the piston that's 100 mils long as well, that all adds to your capabilities of installing a 500 on a bigger pillar E value than you would be able to do on a 400. So if you look at your vantage 500 on 90-degree opening, your pillar depth, your E value, so it's half the pillar basically, can be 245. And on 110 degrees can be 230. You can see you get a lot more flexibility or a lot more capabilities of a 500 if your pillar is a thick pillar. Then you have to go for a vantage 500. Okay, so it's not a stronger motor, it's the same gearbox, everything is exactly the same, except the motor is a little bit longer than the 500 and the piston is a little bit longer than the 400. Okay, so once you've got your pillar maximum, now you can start working out your A and B values. So before we do that, you need to do a checklist. Ensure that the wall bracket is securely anchored. I've seen places where the wall bracket is not fastly secured. Then this gate moves like this. Because you can see even the wall bracket, it swings with the gate, because it's not fastened or secured to the wall properly. Or it's pulled out there using roll bolts. I personally don't like roll bolts because it vibrates loose and it rusts. But it's alright, but just make sure that you do maintenance on it because they do start to wear out a bit. Or if you use chemical anchors, or depends on how you want it, make sure that your brackets are properly secured, your wall bracket, because that's the connection that your motor has with the wall. And there's a lot of force that the motor is actually pushing onto that bracket because it needs to open and close the gate. So if the bracket is not secured properly, then it's gonna flex and you're gonna have a problematic motor. Or it's gonna look like it's doing this while it's opening because it's not secured. Okay. Then ensure that the operator maximum stroke is being used. Yeah. I would also say maximum. You should have maximum, but always 1 or 2 turns back. What I mean by that is this one is actually on its maximum. So if I look at this, so this is the motor, and it's pulled to its maximum. So I would rather say pull it out to its maximum, then turn maybe 1 turn or another turn back, and then you can now determine where you put your wall bracket, or your gate bracket. Okay, so we're saying must be utilized to the maximum, yes, but maybe then 1 turn maybe back. You've got, because then it doesn't push out. There's a little, depends on which motor it is, but I would say maximum might be not the right word there. So maximum minus 1 turn, if I can say that. Okay. Get anything back here? Okay, but yes, let's say operator the stroke must be turned out to its maximum minus 1 turn, maybe 2 turns. Why would I want to do that? Because this one, if you look at this one doesn't sit exactly straight to the top one. So I would say, it's easy, let me just turn it 1 more back or 1 more forward. But it's already on its maximum, so I couldn't turn it. So if I want this one flush with this one, I have now to move my bracket. You can't see now my gate bracket. I have to move it here now for me to have more flexibility to open and close it a bit. So that's why I would say 1 or 2 turns. 2 turns will be the best because then you've got some flexibility on making sure that the gate stops exactly where you want it to stop in its closed position.
So turning it back, it reduces the stroke out.
Yes. Okay. So if I turn it back now 1. You'll see this gate now will be then more open.
Oh, okay.
So I can actually, for you guys to see, but you're not going to see there, but okay. So I would say maximum, maybe 1, minus 1, or maybe 2 turns, if you can.
Yes, that's it.
Okay. Any questions?
Yes, I do have a question.
Yes.
And it goes back to the E value. When I was looking at the drawing that you
Yes.
I thought that the impact of the E value would be to limit the swing to how far it would go, right?
That's correct. Because when the gate can't open further than the E value because in the pillar.
Yes. That's incorrect now.
Yeah.
For the same.
So we'll get to the A and B value just now. It's just the E value. You need to know what your E value is before you can determine the angle, and then it will guide you to your B and A values, your A and B values. Okay. Very, very important. Only use V series cable for insulation. I've seen so many sites that the client or the installer didn't use our Vector or V series cable, which is a cable. It's a 6-core. And it's shielded. It's a cable. Unfortunately, I have a little piece somewhere, but I'm not sure. Someone cleaned it yesterday afternoon when I finished cleaning or did here, and that cable's not gone. But this cable, there's a thin foil type of screen in it, so it prevents any interference from electric fence. It's our main culprit, or any interference from mechanical interference to this controller. Because there's DOS sensors. There's a DOS sensor on the motor, and it gives a pulse to the controller, and that's how we count. And if that pulse gets interrupted by the fence, adding or taking away that pulses or interfering with that quality of the pulse, then we start having issues. A lot of times you tell a client, switch off, if you're having issues, switch off your electric fence and see if it now starts behaving. If it starts behaving, you know, okay, there's somewhere your electric fence is bleeding through the metal, and so at one way or another, it's actually interfering with the count of the motor, because the cable you're using probably is not a screen cable. So it's very important to use a screen cable.
Any other screen cable will also work.
Yeah, but don't go now Cat 6, which has also got a screen, because that's twisted. And we are not twisting it. So now we're adding to the inductance of the cable. So don't go now twisted pair and a screen. So that's why I say rather use V-series cable. Okay. It's not twisted. It's got a thicker positive negative cable for the power of the motor, and it's got smaller little cables, purple and blue and red and black for the DOS sensor to count. Yes, the cable is a little bit expensive. I know it's not the cheapest, but it's definitely the way to go. We, or our field technician, if you have an issue on site, let's say you call us, so listen at this vantage is throwing the stories out. Maybe not so Malcolm, our new one, we had another technician, Rudolph. He will go to your site. The first thing he'll look at is this cable. If you haven't used this cable, he'll turn around, sorry, sort out this before I come back. He won't even try to entertain you or try to see the problem. If you see you didn't use this cable, he will walk and say, not a problem, fix this, still an issue, then I'll come back. So he was very adamant. Malcolm is not so, he's not so, let's say, not so bad as Rudolph was, but it's a good thing, because this is not, a lot of times, this is where the issue comes in. They're using, like someone take trailer cable, which is like a cat tie, but it's got 7 cables in it, which is not shielded. So it's nice and thick cable, but it doesn't protect any outside interference from the world into this controller. Then you have the DOS issues. Then it doesn't work, it's jerky, it doesn't count, it goes into collision because the cable's not good. So it's important to use the V-series cable. Okay, must be shielded. And then leave a 35 centimeter loop on the cable, 315 volt. So you can see here. So there's some. If you need to cut the cable shorter to make a new connection, there is some room for adjustability. Should something happen. And try to, if it's outdoor, try to put it in sprag tube. So I conduit that can twist for the sun, or maybe for the. I've seen clients' dogs charring this cable. Then obviously there's damage to it. Not that sprag will also stop him from charring, because eventually he's going to get through it. But yeah, try to put this also in a sprag tube, so it just protects it a little bit more. Good. And then, if the gate is more than 3 meters in length, then try to see, if the client's got money for it, try to sell him and install a gate lock. Because if I really want to, doesn't matter how strong you build your B value, if I really want to, I can push this in and I can start bending stuff and break it, but I will probably be able to get into your property, especially if there's 2 guys. I say, okay, you pull this one, I push this one, you can get in. But if you've got a gate lock here, then obviously that's going to be a lot more difficult. And obviously with 3 meters, you've got a lot more leverage on the 3 meter gate than you will have on a 2 meter gate or 2.5 meter gate. So the longer the gate, let's say we recommend, if it's more than 3 meters, try to sell or install a gate lock or mag lock. So it's something protects the gate from not just being pushed open.
So if it happened by mistake, maybe someone presses the remote, if you locked the gate manually, isn't it gonna affect the remote also?
So if you lock the gate manually with, let's say, with a chain and a normal lock, yeah, you've got to, and it's going to happen that you one morning you're going to not think, and then before you unlock, or someone wants to open the gate before you went out the morning to unlock the gate, if you lock it manually, you're going to, once you damage it, it's just going to go into collision. But if it happens every day, yes, there's going to be some wear and tear on the motor, especially on the gearbox. So yes, try not to do that. Try not to do a manual lock. Try to have a lock that gets commanded by the controller. The controller will unlock the lock before it actually starts moving the gate. I'll show you now how we doing it. I'm actually unlocking, when I press this button for this motor to open, it will actually unlock this lock. I'm doing it wirelessly. I'm doing it wirelessly, but you can do it hardwired or wirelessly. But you'll hear it. When the moment I press a button, you can hear this one will click, and if I obviously do the the opening, it will open the gate.
Okay.
So yeah, but the controller will tell the lock to open just before it actually will start physically moving the gate. So try not to have a manual lock with chain, because you're going to forget it, and eventually there's going to be some issues. Okay. Oh, you see this battery's going low. Damn it. Alright, then ensure that the opening closing angles conform to the installation guidelines. So that 90 degree and opening of 110 degrees, make sure that it can, the motor will be able to do with your E and A and B values, the motor will be able to conform with the guidelines of how we say you should install it within the parameters of the A and B values. Okay. And make sure that the motor can deal with the wind loading. So if it's a solid gate and it's very windy and it's a big gate, then say, okay, maybe you say we need to quote you 2 motors per leaf. A leaf is basically one side, the other leaf is another side. So it's a double leaf or single leaf. So then you can maybe say, let's put 2 motors on one leaf and another 2 motors on the other leaf. So you can have 4 motors together, but they work 2 on one leaf and 2 on another leaf. Because then it will be a stronger push force or pull force that the motors can do on the gate, if it's a solid gate. Okay. Now we get into inward opening with our values. So here is our pillar. Here's the gate in the closed position. And here is our E value, which is the center of the hinge to the corner of our pillar. So that's our pillar depth. Here's our A value, which is the center of the hinge to the center of where we want to put our bracket. That's our A value. Alright? And our B value is the center of the hinge to the outer side, or the center where the motor gets attached to the bracket. So if you can get your A and B and E values, if you can get that together, could also obviously making sure that your Z value, you can do 90 degrees. If you do this correct, your A, B and E, then you've done installation right. And this is where a lot of installers gets it wrong. They don't look at the A and B, they will just go to site, they will put this bracket on with the length we give you, and they'll mount the motor and then extend it to its fullest and then fit the gate bracket, and that's it. Not even looking at the manual, not even looking at what the angle should be. And then 9 or 10 times it does work, but sometimes it will give you issues, or it can definitely give you issues. But if you do your A and B values correct, then this operator should give you no issues. Okay, so let's have a look. So there's our A, there's our B, and our E. You understand what your E is? Is your pillar depth. Okay, that's from the center to the corner. And that will determine what your A and B can be on a specific 400 or 500 motor, depends on the motor, and depends on the angle you want this gate to be able to open. Okay, so your E value runs horizontal. Okay, and that's from the center of the hinge to the center of where you want to mount your motor. Your B value is looking from the top now, is working towards you. So there's your B value. There's a gate closed, there's a pillar, and that's your B value. So there's your A value, and there's your B value. Alright. And there's your E value, which is your center of the hinge to the corner of your wall, of your pillar. So let's have a look. For example,
does the E value have to be at the center necessarily?
What do you mean? No. So let's say they've moved this gate. So the E value is always from the center of your hinge, which is the gate, to the corner of the pillar.
Yeah.
So if they move that gate there, then obviously E value is less. Okay. So the E value purely is what is there on site. This you can't really change unless you tell them, listen here, this pillar is 600, and on the vantage 500 we can go 245. So if this is center, that means this is 300. This is out of spec. So we can't put a motor on here because this is 300. We can only go up to 245 on 90 degree. If you want 80 degree, then we can have it. Maybe then we can have an E value of 300. But it's still not. We don't like it to be. So maybe we need to start cutting out some of your pillar. So your E value gets determined on where your hinge or where your gate is mounted onto the pillar. And normally it's in the center of the pillar.
Yeah.
But it doesn't have to. It depends on how the guy who installed the gate, where did he put it?
Yeah, when you wanted to establish that, yeah.
Okay. So let's say on a inward swing on a vantage 400, 90 degree. Okay, so we're going to say, okay, what is our E value? So we measure it. We say, okay, 160 millimeters. Okay, so we've got that. That's how, this is what we got on site. This is what we're working with. Our E value is 160. So now we say, okay, 160 on vantage 400 on 90 degree, because they will give you a table for 90 degree, 100 degree, and 110 degree. So this will be the table that you will see on a 90 degree in the manual. So you say, if your pillar is less than 165, which it is because we are running 160, then your A value should be 145, and your B value should be 240. So you are working, you're getting this from the site. This is what you're getting. I've got 160, right? I've got a vantage 400, yes. I want 90 degree. So you look at the chart in the manual. What does 90 degree give you? It tells you, okay, if you are less than 165 millimeters, which we are, then I know I must make my A value 145, and I know I must make my B value 240. If you work in these parameters, this motor will give you good operation, no issues, providing using the right cable. If you can still do this and use the wrong cable, then you're still going to have issues. Okay, so there is my 145. Okay, that's my A value. Okay, and there's my B value, 240. So we know you need to mount your bracket, your wall bracket must be mounted there. Your A value and then your B value, the length of it. Okay. So now, remember, we give you this wall bracket, which I think is 170 mils in length. But now we've got, now to work out how long we need to make the bracket. How long, because our B value must not be more than 240. So you take 240, because it tells you your B value should be 240. Okay, so, okay, what is our pillar depth? 160. So you take 240 minus the 160, you get 80. This tells you you need to cut that bracket to 80 mils. This bracket to mount the motor must be 80 mils. Then you weld it to the bracket, to the wall bracket, and then you will be, total will be then 240 B value. So let's work it out. So there tells you we need to cut 80 mils away from our bracket, because it's 240, which should be our total B value. But now we say, okay, well, we've got a wall that's taking a big part of that 240. So what is the wall? Pillar depth, which is 160. We take that off and we get 80, and that tells us our wall bracket must be 80. So if we put this 80 mils here and we add this up, this will be 240. All right. If you understand, because this is basically probably the most important thing that you need to learn today. Yes.
So that 80 mil
Yes.
will be from the center of the hole.
Yes. Yes.
Backward.
From the center of the hole
The back.
to the back, where it gets mounted to the wall bracket. So you'll see we need to cut this, and this needs to be welded onto the wall, onto that wall bracket that will be there. So yeah, it's the center of the hole.
I think more understanding will be in practical when you're looking at practically.
Yeah, so my tape measure, I'll get it now. Hey, 5 minutes, then we've got a tea break, or smoke break. So yeah, so I'll bring my tape measure. We can measure it. Actually, use my toolbox, which is down there. Then we can have a look at it and see. You can see what your A and B values are. All right, but this is important. If you understand this, then nothing else can go wrong with insulation, mechanical way. Okay, because if you do this wrong, then you're going to have a motor that's temperamental and not working.
Yeah, it's more practical because the rest you can always do the research. But if you know to do the settings right, then
correct.
The rest can be.
Because from here, if you do something wrong here, then you're mounting your gate bracket on the wrong place. then you might not have a fully opening stroke of 90 degrees or less. Or you'll have a very weak gate, meaning your angles are not right, so it hasn't got the power to open and close the gate because it's almost behind it, and it needs to pull something that's behind it, you know. So this will determine your success or failure of the installation. By doing this wrong, look, you can have maybe 1 or 2 mils, you know, doesn't have to be exactly 240, but we prefer you being as close as possible versus what your pillar depth is. So if you've got a pillar depth of 175, then it tells you, okay, your A value should be 130, your B value should be 250. And then you work out, obviously, 240 minus 175, it will give you then your measurement that you need to cut your bracket. Yes?
And if it's, let me say it's 143, 146, 8 value, not exactly 145,
Yeah,
it's
look,
just near.
yeah, so if you really can't be so precise, it's not so much wrong, although it is, but you know what, there is some little bit forgiveness between the A and B values. Like I said, I can make my B value a little bit more, but then my A value should be less than. If I can make this a little bit stronger, I can make this 245, but then I should not have a value more than 240 then maybe. Because if you take from one, you need to give it to the other one, basically. So if you want a fast moving gate, you can make this 150 maybe, and this 230. But then your B value is not strong, so then that motor means there's not much security. Someone can just easily push it. But you say, no, I'm installing a gate lock. So I'm not so worried much about the strength of this motor, stopping someone from pushing it open to get access to my premises, because I've got a gate lock. So I can make my B value a little bit less to make the motor faster now, because now my A value now and the motor can be a little bit faster. But I'm taking away some security. But if I've got a gate lock, then the security is not so much of a compromise there.
So on its own, the motor, it can't resist when someone is pushing it on its own, except if it's having an automated lock.
So we've got positive close mode that you can have enabled, but then you need to have a pin in the middle of on the ground, on the paving. You need to have like a flat bar or